So Lewis structure over here, we are using your Lewis dot symbol. Just very quickly, we can go through that. Lewis dot symbol, the most important thing, ladies and gentlemen, valence electron. And kind reminder again, periodic table will not be given during the exam. So you cannot look at the periodic table, oh dia group 2, so valence electron 2. Tak ada, dalam mimpi pun tak ada. So there is only one way that you can know the valence electron. SPDF notation by using proton number given. That's it. So dalam mimpi pun kamu kena boleh tulis SPDF notation. Writing your SPDF notation should be as easy as breathing in your oxygen gas. Clear? Okay, everybody should be extremely good. So your Lewis dot symbol over here ada a few cara. Most likely we'll be using two methods. If I'm having an element, okay, the method that I always use is the dot form. 1 dot, 2 dot, 3 dot, 4 dot on the left, right, upper, lower. And then you pair up the dot. This is the method that I will always use, using the dot. I know some of you in school will be using the cross. The cross is also acceptable. Mana-mana cara yang kamu selesa, sama ada cross atau dot, saya terima je. Okay? Saya akan biasa guna dot. So, kamu akan nampak saya guna dot banyak. Okay? Tapi dua-dua cara saya terima. Kind reminder, when we are talking about Lewis dot symbol, your electron always come in a pair. When your electron always come in a pair, your electron should always be located just like that. Okay, exactly like what we have on the screen at this moment. It will be wrong when you arrange your Lewis dot symbol like this. Katakanlah, kamu letak Lewis dot symbol kamu 8 elektron miswang, so 8 titik. Oh, no. Okay? Jangan buat macam tu. Ataupun kalau siapa-siapa yang kamu nak letak, 8 tu kamu susun macam ni. Okay, suka hati hang lah. You never care, you know? No. Okay? Pilihan yang diberi hanya adalah satu. You can only use dot or crosses. Other than that, everything as given. Clear? Alright, next thing. Before we move on, important thing, because your dot and your cross right now represent your electron. Jangan hantar kerja kat saya, ataupun quiz, ataupun test like this. Tak nampak apa, betul? Apa benda miswang? Like this. Like this. Like this. Get what I mean? Orang tua ni mata tak nampak weh. When it's a dot, make sure your dot is significant and visible. Is that clear? Alright, because the dot right now represent electron. So if you're giving me a dot like this, it's nothing over there. Clear? Especially manusia-manusia yang suka guna pen that what not strong enough, alright, not significant enough, and you're using pencil that is, I don't know, you buy at Shopee, 100 pencil is only 10 cents, I don't know what is that. Jangan buat macam tu. Tambah-tambah, everything is online right now, and therefore everything is scanned. So make sure every single dot is significant and clear. And good news over here, look at the valence electron and look at the group that I give to you. We only play along with the S block and also your P block. Therefore, we don't have any issue with the D block over here. Lewis dot symbol, the best thing in Lewis structure is D block kita tak banyak cerita. Kita akan banyak cerita pasal S block and P block. D mana? That's why you only need maximum 8 valence electron. Sebab bila kamu bermain dengan S block and P block, bear that in mind, S block 1s2 ataupun 2s2, that is your S block. Betul? 2 valence electron, max. Kalau dia adalah P block, you have your group 13, 14, 15, 16, 17, 18 tak ada sebab 18 dah tak payah buat apa dah. It's very, very stable. So your valence electron will only be 3, 4, 5, 6, 7. Dia takkan lebih 8. Sebab tu cara dia susun adalah 2, 4, 6, 8. Easy? Simple. Okay? So Lewis dot symbol, cara yang paling senang when your valence electron is 1. I think the easiest example over here, sodium. Group 1, 1 titik. Letaklah titik tu kat mana? Kiri, kanan, atas, bawah. Doesn't matter. Janji 1 titik, janji titik tu jelas. Group 2, same thing, potassium 2 titik. 2 titik asing. Okay, apa yang saya nak tunjuk kat sini adalah a way of arrangement your valence electron. Remember your Hans rule? Single electron first. Single electron first. Okay. Alright. Same thing. 14 I think most likely we have carbon. Most of the time. Carbon 4. So 4. Okay. And then you have your nitrogen. Let's say 5. 1, 2, 3, 4, 5 pair up. Clear? Issue? Tak ada? Good. Move on. Why we have bonding? Okay, because the next thing that we are going into is your ionic bond, covalent bond, and also dative covalent bond. One new thing today, okay, compared to your SPM. So why octet is something we have discussed in your topic 2 that day, and also topic 3. Formation of ion, remember? When we become cation, when we become anion. Very simple over here. If I'm having my X11, my SPDF notation. Nadira?
1s2, 2s2, 2p6, 3s1.
Alright, Nadira, what ion would X be?
s1.
I repeat my question. What ion would X be?
Ionic. I'm sorry, madam. Sorry, Miss, tak clear.
What ion X akan jadi ion apa? Kalau X nak jadi ion, X akan jadi ion apa? Ni bukan benda topik 4 ni benda topik 2, topik 3, betul?
Cation and anion tu.
Ion? Cation boleh, anion boleh, ion.
Anion.
What is the charge?
Positive one.
Thank you. Setuju yang lain? Okay. Positive one over here because the valence electron is 1, 3s1. Therefore, when we remove the valence electron, it becomes 1s2, 2s2, 2p6. And why we become X positive over there? Why we become X positive and remove the 3s1? Guys, octet, as I keep repeating last lecture. Okay? Kenapa kita jadi ion? Kenapa benda tu jadi macam tu? Sebab saya nak jadi octet. Same thing like your oxygen, oxygen over there. Fazana, Fazana Izati.
Yes,
SPDF notation.
1s2, 2s2, 2p4.
Alright. So you have your 1s2, 2s2, 2p4 over there, guys. So bila oxygen nak jadi ion, Fazana, back to you. What ion would oxygen be? And why?
O6.
Oxygen?
Oxygen.
Positive.
Negative, I think.
Tadi baca SPDF notation sebab boleh jawab kuat je suara. Sekarang suara tiba-tiba jadi tak okay. Come on, girls. Louder. We'll wait. Simple question. Tak apa, nanti saya bagi tahu Cik Jadilah. Weh, Fazana tak boleh buat. Oxygen 1s2, 2s2, 2p6 jadi ion apa pun tak tahu. Come on. Oxygen?
Negative 2.
Negative 2 or 2 negative?
2 negative, sorry.
Alright. And because we accepted the 2 electron, guys, So the 2p4 over here will then be a 2p6 because oxygen from neutral to become 2 minus. Same reason. Kenapa jadi macam tu? Sebab sekarang valence electron saya 6. Betul? So, bila saya terima 2 elektron, I plus 2 electron over here, I become 8 electron. And that is my octet. So, all this while, semua yang kita belajar, kita sebenarnya nak buat satu benda. Kenapa dia jadi cation? Kenapa dia jadi anion? One reason. NS2 and P6. Apa maksud NS2 and P6? The N must be the same. Which means, if I am having over here, 2s2, 2p6, 2s2, 2p6, that is my octet. I can have 3s2, 3p6, that is also my octet. I can have 4s2, 4p6, that is also my octet. So, apa maksud NS2 and P6? Octet, 8 elektron. Okay, with one condition guys, the N must be the same. Simple. But of course, we are not going to go for the simple thing. Octet tak salah. Tapi octet adalah the term that you learn in SPM. It's absolutely right and no wrong. Until today, I'm still using octet. But I have more different stability. Why we have different stability over here? Because we have D block. Dulu SPM tak pernah cerita pasal titanium, ferrum, zinc, betul? Alright, tapi hari ini kita ada D block. So, bila kita ada D block, we have different stability. Okay? Bear that in mind, different stability means they are still stable. So, the noble gas configuration is what the one that we have just now, which is your NS2 and P6. Your noble gas configuration is the octet that we are talking about. Cuma satu je sayang, tukar nama. Hari tu nama senang, octet. Sekarang kita macam tukar nama, bagi nama high class sikit lah. Kan nama paling panjang selalu high class kan? Nama apa pun ayat sampai 5-6 perkataan. Nampak macam high class lah. Nama je lah high class, orang macam tu juga. Oops. Right? Wan pun sama. Wan, kenapa makan rendang sangat, Wan? Not even over 20. Come on, girls. You can do better than that. Your octet over there is the noble gas configuration, exactly the same as the octet. So nothing much to talk about over there. Okay, it's the same as what we have been talking about. Yang saya nak tengok, dan saya rasa yang kamu nak tengok pun adalah apa benda tu pseudo noble gas configuration. If you learn in your biology, you realize that your pseudo is like fake. Kalau tak silap saya, false. Betul? Alright, in biology, it's actually bringing the same term, same meaning. Apa maksud false noble gas configuration? Apa maksud pseudo noble gas configuration? Your 3D. It's actually your 3s2, 3p6, 3d10. This is your pseudo noble gas configuration. And obviously, sayang, bila dia duduk bawah stable electronic configuration, guys, of course, this thing is stable. Kenapa dia nama pseudo? Because it's not exactly the same as your octet. Your octet adalah S2P6. Betul. Tapi kat sini adalah S2P6D10. That's why I'm pretty sure it's 3. Sebab tu saya tak guna N. Sebab siapa je ada D? 3 je ada D, betul? 1 tak ada D, 2 tak ada D. That's why Miss Wong can put straight away it's a 3. 3S2, 3P6, 3D10. It will then have the exact stability. It will then have, I wouldn't use exact, I would say similar. It will have a similar stability as the noble gas. Dia akan stabil macam octet kita. Dia akan stabil macam noble gas kita. Cuma dia slightly different dari segi bilangan elektron dan kedudukan elektron. Bilangan elektron akan berubah jadi 3D10 ada sekali. Tapi stabil, sangat stabil. Stabil seperti noble gas kita. Okay? And then last but not least, half-filled orbital. And the half-filled orbital, guys, that we will focus 100% on is your 3D. 3D5. Alright? Tapi, bila kita kata half-filled, sayang, yang stabil bukan 3D5 je. Kita kena bagi penuh. 3S2, 3P6, 3D5. Yang ni baru kita maksudkan half-filled. Selalu budak akan salah faham. Oh, bila half-filled orbital, saya tengok 3D je. Sayang, depan tu tak payah penuh apa? Takkan depan tu kosong. No, we have Aufbau rules, we have Hans rule. Orang tu kena penuh, betul? So, the correct configuration, the full configuration for half-filled orbital is your 3s2, 3p6, 3d5. Of course, whenever we sit under stable, they are stable. All right, they're 100% stable. Example that I can give to you, noble gas, tak bincang dah. I give you a lot of example during topic 2, topic 3 on how to become ion, cation, and all that. I don't see a purpose over here. Noble gas, okay? So noble gas that I can have, let me look at my list of my, what do we call that? Proton number. On tua tak ingat. Noble gas. Zinc, easiest. Zinc 30. Okay? I want SPDF notation. Miss Wong?
1s2, 2s2, 2p6, 3s2, 3p6, 3d10,
3p6, 3d10.
4s2.
Read again, all the way from 1.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10.
4s2, 3d10. No matter how you arrange, guys, I understand that you can rearrange to become like this. You can rearrange and then you can rewrite it to become your 3D sitting there. But when you read, when you fill up the electron, you must always fill the electron into the 4s2 first, then only 3d10. Is that clear? I don't see a purpose to repeat this way. So that is my zinc over there. Okay, that is my zinc over there. And 1. Valence electron duduk kat mana? Valence electron belong to who over here? For S2? Je. Three P6. Hannah, what happened to your friend, Hannah? I'm still waiting. We talk about valence electron very slowly, very carefully. Did I? Did I, Hamza? Hamza, Miss Wong ajar tak, Hamza?
Ajar. Yeah.
So, Hamza, who is your valence electron over here? I probably,
3D.
Thank God. Thank God. Or else mungkin saya nak masuk tutor kamu, tengok cikgu kamu mengajar macam mana. Thank God. Valence electron over here, 4s2, 3d10. Okay, 4s2. Duk marah orang macam tu. Sekali saya tanya Himan pun tak boleh jawab. Iman? Iman ada Himan? Alright. So your valence electron over there, 4s2, 3d10. Okay. Dan Himan, tak berani tanya orang, tanya budak setinggi tapi Han tak boleh jawab, Han jaga. Himan, kalau zinc nak jadi 2+, elektron buang dari mana dulu, Man?
Dari 4S dulu.
Thank you. Kenapa kita buang dari 4S dulu?
Sebab dia outermost, dia paling luar lah.
Alright, sebab dia paling luar lah. Okay, itulah macam itulah Miss Wong ajar dalam kelas. Sebab dia duduk paling luar. Yes, sebab dia adalah outermost electron. Okay. So your zinc 2+ over here, we will remove your 4s2 first. Therefore, you can see, after you remove your 4s2, nasib baik Human boleh jawab. Taklah malu sangat kan, Man? Okay, quiz nanti boleh consider cancer. Okay. So over there, you can see your pseudo-noble gas. The reason why zinc akan jadi zinc 2+. Okay. Why we always have zinc and then zinc 2+ as an ion. Okay. Reason, because this is as stable as your noble gas. Walaupun benda ni kita panggil pseudo noble gas configuration. The stability, the type of stability adalah pseudo noble gas configuration, tapi dia adalah as stable as your noble gas configuration. Alright, and that is the reason why we are learning this, because we have d orbital right now. Okay, next, half filled. Iron 26. Okay. Shafiness. Yes, go. SPDF notation.
Yes. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4.
Huh?
3 3d6.
Okay. And next question. Iron boleh jadi Fe positive as I have in my video. Fe boleh jadi 2 plus. Okay. Fe boleh jadi 3 plus. Ni adalah proses karat kamu. If you know your iron, Fe is iron. Alright, logam kamu. Logam pula. Iron kamu yang banyak kita gunalah dalam harian kita. Alright, besi kita tu. Dan besi kita karat. Okay, obviously besi kita karat. So karat yang final, karat the rust that we call rust yang warna perang tu is actually this. And that is the final of the Fe. Your Fe maximum boleh jadi Fe3+. And we will see why over here. Why your Fe can be only Fe3+, what would be the SPDF notation of the Fe3+? Zulaika, Siti Zulaika. H8P4.
Yes, Miss.
What would be the SPDF notation of this?
1s2, 2s2, 2p6, 3s2, 3p6, 3d5.
We know that kalau dia jadi, alright, we know that kalau dia jadi Fe+, dia sebenarnya akan buang elektron pertama pada 4s. So dia akan buang, tak ada masalah dia nak jadi Fe. So dia buanglah satu-satu kat situ. 4s to 4s1. Lepas tu Fe2+, dia buang lagi. Alright, tak ada masalah, dia boleh buang. Elektron kedua, buanglah, nak keluar lah, tak ada masalah. Macam apalah, nak keluar lah, tak ada masalah. But why after this is still not so stable? If you ask me, teacher, kalau macam tu Fe positive, Fe2+, ada tak? Wujud tak? Wujud. Stable tak? Tak stable. Dia duduk lama tak kat sini? Tak lama. It won't last long dah. So, what happened is your Fe+ will become Fe2+. Your Fe2+ will then finalize at the Fe3+. Why it will then finalize at the Fe3+? Simple. Stable. The stability of it over here will be your 3s2, 3p6, 3d5. That is your half-filled 3d orbital. Okay? The stability of the half-filled 3d orbital. Makes sense? So, dua tu, kenapa kita ada 3 jenis stability yang kita belajar sekarang? Okay? Bukan sebab apa weh? Satu je benda. Kita nak benda tu stabil. Dan dua ni adalah, yang ni adalah yang kita banyak belajar. Noble. Okay? Noble gas configuration. Dua ni sebab kita ada D block. That is the reason why kamu ada 2 extra stability dalam syllabus ini. Okay? Which are very simple, which will be proven easily by using your SPDF notation. Therefore, you need to be able to write your SPDF notation as easy as you're breathing. Alright, probably easier than you're breathing because I'm going to choke you very soon. Rasa macam kena buat quiz tiap-tiap minggu. Right one? Then you will bother to listen to my lecture. Yes, because you have quiz tonight. Chemical bond. Okay, next. chemical bond. Why they become ion? Tadi kita dah tahu kenapa dia jadi O2 minus, kenapa dia jadi Fe3 plus, kenapa dia jadi aluminium 3 plus, chlorine minus, and whatsoever. Dia stabil. So the story will be the simplest thing that you always come across. Sodium chloride. Betul? So the story will be kenapa sodium akan jadi positif, Cl jadi minus. Bila kamu kata, I need to accept an electron to become Cl minus. So the next question over here, before this, I only say, oh, you need to accept electron because you want to be stable. So the next question is, where the electron come from? You want to accept electron sebab you nak stabil. Electron datang dari mana? Right? You want to remove the electron. Okay, you remove the electron and then the electron goes to who? So, why we have bonding? Because this guy will remove the electron. Remove one electron generally. And that one electron akan berenang dalam beaker kamu. And that one electron will then go into here, accepted by the chlorine. So you're moving a bit better right now. You're moving into deeper. Before this, you only say, I want electron or I remove electron. And right now, you need to think, my electron removed and given to who? I want to accept electron. The electron that I accept is from who? You need to think that way. So dengan kata lain, we have partners. We have partners. Alright? We have bonding over here. We have 3 types of bonding. Ionic bond. Okay? Covalent bond. The one that you always come across. Ionic bond is between positive and negative charge ion in an ionic compound. Covalent bond is the word sharing. Alright, where you have 2 atoms and the electron are shared between them. That is the main difference. Betul? Because to become a positive charge, you need to donate electron. To become a negative charge, you need to accept electron, as we all know. So, kat sini ada pergerakan elektron. Elektron akan dibuang dan diterima. Tapi kat sini, covalent bond, elektron akan dikongsi. Betul? Dan I want to change something in your SPM. Huge thing. Very huge. Which is, your ionic bond before this, you say, is between metal and also non-metal. Setuju? And then your covalent, you always say, is between non-metal and also non-metal. Setuju? Biasa dengar kat SPM? Kalau ingat lagi apa benda yang hang belajar kat SPM lah. Alright, sebelum SPM pun dah lupa aptar lagi. Lepas SPM ni semua dah bagi balik kat cikgu, cikgu suruh pulangkan. Alright, if you remember, you come across this thing. And in here, they are wrong. They are generally correct. 99% they are correct. One example, aluminium fluoride is an ionic. But aluminium chloride is a covalent. Aluminium is a metal. Yes, it is a metal. But this metal, when partnered up with your chlorine, it will then prone or it will then mold to become covalent rather than ionic. Okay, main reason yang saya boleh bagi tahu, malas nak explain tanya cikgu tutor kamu. Main reason because of the size and because of the charge. It's not a strong positive and it's not a strong negative. So rather than bagi dan terima, there will be more on sharing. Sebab dua-dua orang tak kuat. Bila dia tak cukup kuat, dia tak mampu nak bagi kat orang tu dan orang tu tak mampu nak terima. So bila orang tak mampu, kita more on sharing. Okay? Make sense? And we'll talk about that if, don't worry. We'll talk about these two first. Ionic bond. 2 benda. Dalam soalan, kamu kena fokus 2 perkataan penting. 1 perkataan formation. Alright? 1 perkataan draw the structure. Okay, 2 keywords. So I'll show you the formation and I'll show you both of it. So my ionic bond, one of the simplest that I can have. We use the simplest first, boleh? KCl. Alright, nak tunjuk cara jawab dalam exam je. So we know that KCl coming from where? First thing, color formation. Color formation, first thing, ladies and gentlemen, you need to know who made up who. So you need to know formation of KCl adalah K positif tambah Cl minus jadi KCl. Agree? Okay, tak habis lagi. This is not what we want. And to show the formation, you need to start off with the Lewis dot symbol. Alright, you need to start off with the Lewis dot symbol. Muhammad, I don't know how to pronounce your name, boy. Muhammad E-I-S-H-R. How to pronounce that name?
Ishraf, Ustaz.
Ishraf. Ishraf.
Kalau ni Afi pun okey. Afi.
Asri.
Afi, A-F-I-Y.
A-F-R-Y. Afri.
Afi.
Alright, yes, Afri. K. How many valence electron?
1.
1. So 1 dot. Chlorine.
1.
Huh? How many valence electron?
7.
7. Thank you. So my 7 should look like this. And dalam exam, touch wood. Alright, K dengan CL patut ingatlah 1, 7. Touch wood, masuk exam blur, blank gila, tak gaban apa benda ni, lupa tak ingat. So how do we get the valence electron? Based on the proton number, alright, based on the SPDF notation. Sayang, the moment dalam exam kamu kena teka, saya rasa 1. Sayang, rasa tu salah dah. We don't have Ajinomoto, tak ada mie goreng, tak ada nasi goreng, tak payah rasa. SPDF notation. Faham? Tak payah hafal. Okay? So, apa maksud formation? Formation means you need to show from the beginning till the end. This is your beginning. Okay? This is your beginning. So you need to know what you are using. Alright? That is the formation. Show. Okay? Next. Next thing that you need to have is the arrow. You need to have the movement of the electron. And the movement of the electron always from siapa yang donate kepada siapa yang terima. Obviously, potassium donate, chlorine terima. And look at my arrow. My arrow is moving to the electron yang duduk seorang. So my arrow from the electron in the potassium to the electron in the chlorine. See that? Arrow yang saya lukis adalah daripada elektron menuju ke pasangan elektron yang saya nak duduk sepasang tu. Arrow yang saya tak minat. Alright, tunjuk siap-siap arrow yang saya tak minat. Arrow yang saya tak minat. Like this. Dari mana ke mana. Okay. The arrow represent the movement of electron. Therefore, you need to show very clearly the electron is moving from where to where. Is that clear? And the product will no longer be like this. Alright, this is our draft. Your product should be potassium donated the electron, therefore potassium become positive. And ladies and gentlemen, look at the arrow, look at the bracket, look at the charge. Charge duduk di luar. Bracket adalah square bracket. And no longer having any dot on the potassium because the valence electron has been donated. And then you have your chlorine. Your chlorine right now will be 1, 2, 3, 4, 5, 6, doesn't change. 7 is the original. You have 1 extra. And that 1 extra will cause your chlorine to become negative. And this 1 extra coming from here. Clear? And look at the way that I write, guys. Look at the way I write. Between your potassium and chlorine, ada tak ikatan? Boleh tak saya letak satu line? Boleh tak saya letak satu line? Tak boleh. Sayang, it's a force of attraction. It's an electrostatic force of attraction. Positif, negatif. Dia akan automatically tertarik. Okay, dia tak ada ikatan antara tu Tak boleh ada ikatan sebab yang ni positif, yang ni negatif, dia akan tertarik duduk dekat. Therefore, you cannot have any bond in between. See that? and diorang kena duduk dekat. Yang penting diorang kena duduk dekat. And the way to indicate, alright, if the question asks you to indicate the ionic bond. Indicate ionic bond. Apa maksud indicate ionic bond? We know that the ionic bond is between the positive and the negative. Label just like that. Alright, label just like that. Alright, label tengah tu tarik ke bawah, that is my ionic bond. Jangan letak ikatan. Tolong. They are not bond, it's just the name ionic bond. Diorang adalah daya tarikan, it's a force of attraction. So, two keywords that you need to know. Formation. Kalau formation means you need to have from the beginning, what happened, what do you produce. Yang pertama, formation. Yang kedua, when the question asks you to indicate the ionic bond, is the label and then name the bond. Boleh? Senang. Sayang. Like this, 3 markah. Easy. Super easy marks. 1 mark untuk the Lewis dot symbol. 1 mark untuk this arrow yang kamu tak kisah. 1 more mark is the product. Oh, tambah indicate sebab Miss Wong tambah indicate. And kimia susah. And 1 tak dapat per berapa belas mana dapat? Oh my god. Huh? And Fazana 6/30. Hang memang ingat hang buat sungguh, lepas tu Miss Wong tak tengok balik. Come on, girls. Got sick. Just don't like it the moment I analyze your results. Draw the structure will be much easier. Bila dia draw the structure, obviously jawapan hanya 1 markah. Draw that structure. Tak perlu ada beginning, tak perlu ada tunjuk elektron pergi mana. Jawapan kalau draw the structure, jawapan yang kita nak hanya adalah K, positif, Cl, 8 titik kena penuh sebab kita dah terima valence elektron dari potassium, Cl minus. If the question asks you to draw the structure, this is the answer. If the question asking for formation, this whole thing is the answer. Nampak beza? Simple. Yes?
So we don't need to label the ionic bond when they ask us to just draw the structure.
Ionic bond you need to label when the question asks you to indicate or label the ionic bond. Then you label. That is the extra 1 mark. And of course, if Mira feel uncomfortable, you just want to make it easier for you, no matter question asked or not, you can always label ionic bond. No problem. Okay? Soalan keyword dia adalah indicate atau label. That is your answer. Okay? And guys, lukis besar. Lukis besar. Apa kadang-kadang kedekut gila tak gambar. Oh, this whole thing don't squeeze into 1 row of your paper. I know it. Kedekut hampa kadang-kadang kan, you're trying to save the world, you know, trying to be environmental friendly in the exam. Come on, the world don't need you at this moment. You are the biggest pollution on the earth. You know? Breathing in oxygen, but then you got 6/30 in Miss Wong class. You are the biggest pollution, man. You are not supposed to be here. 6/30 tu adalah macam saya bagi soalan tu pada my nephew. Alright. Lepas tu saya bagi Google Form tu kat iPad dia. Alright. On my nephew that I think about 4 years old. Lepas tu dia main tembak, dia boleh dapat 6/30. Nak try? What the? This one I will just show you very quickly. Katakanlah yang susah sikit. Let's say we have aluminium oxide, Al2O3. Bila dia Al2O3, dia ada 2 Al. Cara nak tulis, cara nak jawab. Alright, tadi satu-satu, senang lah. Kat sini kita ada 2 Al. Lukis 2 kali. 1 Al ada 3 valence elektron. Lukis 3 valence elektron tu. Alright. Tambah, jangan lupa tambah. Because aluminium need to react with oxygen to produce Al2O3. So tambah tu kena ada sayang. They are reactant, tambah reactant, baru dapat produk. So 1 oxygen having 6. Alright, so make sure the 6 valence electron look like this. Kena ada 2 yang single. Kena ada 2 yang single. So you need to know that. Kalau tak confident, buat je cara ni sayang. 1, 2, 3, 4 single, 6, 5, 6. Nampak? And the arrow forever single-headed. Kenapa forever single-headed? Sebab kita bagi. Kita bukan share. Kita bagi elektron tu kat dia. Kita bagi elektron tu kat dia. And look at my arrow moving from where to where? Moving from the single electron to the single electron, the single electron to this single electron. See that? Electron pair up. Dan sayang, kalau saya ajar sampai detail macam ni, bermakna kita akan salah kalau kamu lukis salah. Arrow kamu tak lengkap, arrow kamu tak betul, memang kita tak bagi markah arrow. Bear that in mind, arrow 1 markah. Okay? Over here, I have another one. Kenapa Al 2? Sebab 1Al akan donate 3 elektron. Tapi 3 elektron bukan bagi pada orang yang sama. 2 bagi pada orang yang sama, 1 lagi pergi kat sini. Same thing over here. I hope you can see it now clearly. Nampak? Okay? The same reason. Single electron bergerak ke single electron bergerak ke single electron. And then you have another one, and the last one is your aluminium bergerak ke elektron ni. Your aluminium bergerak ke elektron ni. Easy. Nampak? And cara yang paling senang, jangan buat dia dari kiri ke kanan. Jangan letak like this lah, dengan kata lain. Jangan letak like this. Alright? Jangan letak like this. Jenuh. Arrow kamu akan jadi gila. Susah. Tak payah. I always tell my student, ion 1 row and ion 1 row. So kamu senang nak move the electron. Alright? Teknik menjawab. Bukan susah apa pun. Just teknik menjawab. And then your product, of course, you'll be forming your product. Your aluminium over here, 1 aluminium will become 3 positive. Because 1 aluminium donate 3 electron. But I have 2 aluminium. 2 bukan duduk bawah. 2 duduk atas. Nampak beza? Same thing goes to your oxygen. I will have 3 oxygen that right now having 8 valence electron that holding 2 minus H. Kenapa 2 minus H? Because every oxygen accept 2 electron. So 1 oxygen is 2 minus. Tapi saya ada 3 oxygen. Nampak saya? Easy? Alright, Ani, are you there?
Yes, saya.
Good. Najla, are you there? Good. Nampak guys? Easy. Weh, 4 markah tutup mata boleh dapat. And the good news, that's it about ionic bond. The rest of the chapter will be only about one thing, covalent bond. So good news for ionic bond, itu je. So rasa-rasa kalau ionic bond belajar benda ni je dan hang rasa dia tak keluar, mesti akan keluar. Okay? Dia mesti akan keluar. Faham? Alright, covalent bond. Covalent bond, boleh tunjuk contoh yang senang. The biggest difference in covalent bond and ionic bond is actually this type of arrow. Okay, it's actually this arrow. This arrow. Kalau dalam ionic bond, kita guna single-headed arrow. Tapi bila dalam covalent, the biggest problem is they are sharing. So bila they are sharing, they will be using double-headed arrow. Saya nak buat covalent yang paling senang dulu dalam dunia. CH4. So it's carbon plus 4 hydrogen. So carbon, 4 valence electron. Okay? Hydrogen, 1 valence electron each. So saya ada 4 hydrogen. Okay? Your methane over here. The biggest difference will be, saya kagum bila Nadira boleh tak tulis apa, you know, orang lain duk pegang pen, Nadira is like just watching, looking at me. Come on guys.
Miss, saya tulis lah Miss.
Oh, okay.
Tak nampak kot sebab pen saya kat bawah.
Boleh? Saya percaya je bila Nadira kata tulis, saya percaya je Nadira sayang. Okay, good. Writing guys. Alright, I won't be there being your hand. I won't write for you. Okay, biggest difference, look at here. Masih daripada elektron kepada elektron, tapi teruk. Kenapa macam ni? Sebab kita tak bagi. Tak ada siapa bagi dan tak ada siapa terima. Kita share. Alright? Tak ada siapa bagi dan tak ada siapa terima. Dua-dua orang sumbangkan elektron mereka. Alright? We actually contribute our electron and we share our electron. We contribute the electron and we share the electron. So when we share, look at the arrow that Miss Wong is using. The arrow over here, guys, must be double-headed. And when I use the word must be, guys, don't challenge that lah. And then over here, slightly different. We will have bond forming. We will have one bond with the hydrogen. We have one bond for the hydrogen, one bond for the hydrogen, and one bond for the hydrogen. Why one bond over that? The electron is actually sitting on the bond right now. Kalau kamu nak Lewis dot symbol yang 100% betul, yang gila-gila tapi kita tak guna tau, saya tunjuk je. Dia akan jadi like this. Dia akan jadi like this. Kita tak guna ya cara ni, kita tak guna. Saya tunjuk je bagi nak nampak. Alright, your electron from the carbon and hydrogen, one electron from the carbon, one electron from the hydrogen, they form a bond. Nampak? So why a bond? Because we share one electron from hydrogen, one electron from carbon. So in the other words, everybody should agree, satu ikatan, one single bond, one sigma bond, alright, is equals to 2 electron. Setuju? Okay? Sebab itulah dia dapat 2 elektron, satu daripada carbon, satu daripada hydrogen, covalent bond. We'll talk about covalent bond a lot because the entire chapter is about covalent structure. The entire structure. Okay? So, benda yang Miss Wong nak tekankan pada covalent bond kat sini, sayang, this one only. Alright? This one only. Make sense? Guys, very, very important chapter. I would rather go slow than I go fast and you get nothing. So, do me a favor. When I go slow, you start writing. Jangan sampai saya tak buat apa, kamu yang menulis dan tunjuk kat saya. Faham? Okay? When I go slow, I expect you do it together. Kalau saya nak pergi laju, I can go very fast. Okay? So, covalent saya tak nak cerita banyak. Ataupun ada compound covalent yang nak saya buat? Tak ada? Sebab kita akan banyak cerita pasal covalent later on. So, saya tak nak cerita banyak pun. Just nak satu je. Yang ni, oh, tertinggal satu sayang. Indicate. Mana boleh lupa. If the question asks you to indicate the covalent, kita dah ada ikatan macam ni kan? Kita dah ada ikatan duduk elok lah. So this is my structure. Alright, this is my structure nicely drawn. Okay. So kalau soalan minta indicate, senang je. Yang ni ada ikatan. So label je lah ikatan tu. Covalent bond. Yang ni senang. Yang ni tak jadi isu. Sebab ikatan tu kita nampak. Covalent bond. Easy. And guys, indicate macam ni, cikai-cikai macam ni, satu markah dah. Nampak? Satu markah dah. Okay, boleh kita sambung. Alright. Next and last before we end. Dative covalent. Anybody can tell me what makes dative covalent different from covalent? Anyone? From 134. Mira?
It is the bond formed when only one atom contributes the electron.
So which means we have a bond. I have 2 electron and the 2 electron between A and X. Katakan. So the 2 electron coming from who, Mira?
A. Or
X. Betul. Apa maksud dative covalent bond? I use dative covalent bond because I want to show you that they are still sharing. Some books or some notes, they will just write dative bond. It's the same. Why I put in the covalent? Because I want to show that they are actually still sharing. Sebab tu they are still having a bond. And what Mira said just now is, the electron in the bond, the 2 electron in the bond is only given out, is only contributed by one person. Tak kisah A atau X, tapi dua-dua elektron ni kena datang daripada seorang je. Dengan kata lain, seorang je bagi. Seorang lagi tu ambil dan kongsi. Dia tak buat apa. Dia tak contribute apa. Macam apa lah. Miss Wong dia tak contribute. Alright, we are forever dative bond. When can we be covalent bond, guys? Ionic also never mind. I can always give you my knowledge, and I would rather I become stupid than you not doing well. You know that? Okay? I don't mind giving my knowledge to you and then I become ionic, tapi janganlah weh. I don't want to be that stupid. So we will be covalent. But right now, most of you guys is still dative covalent. You're only taking from me. You're not even bother sharing. Too bad. Not good. Dative covalent yang paling simple saya boleh tunjuk. H3O+. Anybody watch? I think you should watch your dative covalent bond video. Kenapa saya letak dative covalent bond video as one separate video? Mainly because kamu tak belajar kat SPM. So, video panjang ionic covalent tak nak tengok. Dative kena tengok. Sebab dalam dative video tu, saya letak basically semua compound dative yang pernah keluar exam. Favorite question dah. So, tengok yang tu. So, kat sini saya tak tunjuk banyak. Saya tunjuk apa tu dative dia. So, H3O+, that obviously come because of H2O, because of H+. Okay? Over here, just I want to show you a bit of Lewis structure that we will go in next week. Okay, memang nak berhenti kat sini. I want to use this H2O, the simplest Lewis structure ever in your life, to show you what is actually Lewis structure. Your Lewis structure was started off with total valence electron. You should have learned. Okay, you should have learned. You should have watched the video and you should have known. Total valence electron means kita akan ambil untuk H2O. Sahaja. H+ tak payah. H+ lah. So, hydrogen is 1. I have 2 hydrogen, so times 2. So you have 2 total valence electron, 4 hydrogen. Oxygen is 6 electron. So the total valence electron over here adalah 8. Yang mengangguk tu ialah yang tak tahu apa benda 1 darab 2 tu, good luck and all the best. Central atom oxygen, terminal atom hydrogen. Another thing why I'm using H2O, because I did a big mistake in my video. I typo. But I have made the correction in the description, so read it. I don't know which video, but I have. I feel stupid the moment I look at it. Alright, so that is my H2O. Oksigen duduk tengah, H duduk tepi. Tolak 4. Kenapa tolak 4 untuk yang tak tahu? Sebab setiap ikatan ada 2. So tolak 4, saya tinggal 4 elektron. And 4 elektron, terminal atom dah tak payah letak. Kalau siapa yang tak faham apa yang saya cakap tu, good luck guys. You need to go and study. Alright, terminal atom tak payah buat apa sebab hydrogen dia dah duplet. So, the 4 elektron yang tinggal akan duduk pada oxygen in a pair. Tolak 4, valence electron forever kena kosong. Okay, try to figure that out. So, I have my Lewis structure of my water ready. So that is the Lewis structure of my water. And then I react with the H+. Knowing that H positive means I have no electron left. Hydrogen ada 1 electron je, neutral. Lepas tu hydrogen nak jadi H positive because I remove that 1 electron. So my H positive, no electron. Dative covalent. Masih adalah covalent, ladies and gentlemen. Masih adalah double headed arrow. From one of the lone pair, that is sepasang elektron, share dengan H+. Masih adalah sharing. Okay? So what will be produced? You will produce a new bond. But before the new bond, guys, everything that doesn't change remain unchanged. Betul? Everything that remain unchanged, salin balik. Tak ubah, tak ubah, tak ubah, tak ubah. Tak ubah, tak ubah, tak ubah, tak ubah. Salin balik. And then you have over here is your new bond with the H. And the new bond, this new bond, is what we categorize as dative covalent. And this dative covalent can have a symbol of arrow. Suren, the arrow heading toward H or heading toward O.
From O to H.
from O to H. This is the way that we label dative covalent bond. Daripada siapa yang bagi kepada siapa yang terima. So daripada O yang memberi kepada H yang menerima. That is how we label dative covalent bond. And at the end of the day, your structure is not complete without the charge because it's a H3O+. Nampak? So dative covalent adalah keadaan kita sekarang. Our relationship right now, only me giving, you give nothing in return. Itulah kita. Sedih kan? I talk about Lewis structure a bit. Untuk siapa manusia yang tak dapat langsung apa benda Miss Mondok merepek, apa tu TVE, kenapa tolak 4, kenapa letak lone pair kat tengah, all those things. Guys, good luck because next week there will be whole thing of Lewis structure only. Okay? And kind reminder before next week, before we go into Lewis structure next week, guys, if you have come across any compound that you cannot do and you want me to show you in the lecture, throw to me. Just tell me in the lecture, okay? Teacher, saya nak teacher buat yang ni. Kalau tak, saya akan guna H2O je lah sepanjang kuliah. Alright? If you come across any compound that you cannot do, throw it to me during the lecture. I can show you. My pleasure. Okay? So if nothing else, go and figure out your Lewis structure and we will continue to Lewis structure next week. Good luck and all the best. Oh, by the way, we have quiz tonight.
Madam, the quiz until which subtopic?
The quiz until which subtopic? Still SPDF notation, valence electron, ion, cation, ion, cation. I'm just not moving from there when you're not doing well. Until semua orang dapat markah yang saya rasa puas hati, your quiz will be on that. SPDF notation, ion, cation, stability. Alright? Noble gas or pseudo or those things. Okay?
Thank you, madam.
Yeah, I'll give you the link later on. Boleh scan ke?
Miss,
Yes?
quiz malam ni pukul berapa?
9.
Okay.
Pendek je. 10 minutes, 20 minutes maybe. Just saya cukup tak puas hati dengan some of your friends' result.
Thank you, Miss.
Thank you, Miss.
Thank you guys. Thank you guys.
Thank
Thank
you,
you.
Miss.
You miss.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you.
Thank you, miss.
Thank you, Miss.
This is the time when everything is working. Line is super good.
Miss.
Thank you,
Yes,
miss.
sayang.
Allah. Kalau yang covalent bond tadi tu kan, kita kena label semua ke satu je pun boleh?
Biasa saya akan suruh budak label semua. Sebab nanti minggu depan sebelum kita dah start masuk Lewis structure sikit, saya akan bagi contoh soalan yang di mana dalam structure yang sama dia boleh ada ionic, boleh ada covalent, boleh ada dative covalent. So kamu kena
Lepas tu
label.
kan,
Yang ionic bond tu dia tak kisah nak panah dia ke atas ke bawah ke.
Tak kisah. Tapi anak panah tu yang kita kisah adalah bergerak dari mana ke mana. Alright, yang tu kita kisah. Dia nak lengkung ke bawah, lengkung ke atas, tak kisah. Janji dia dari tempat yang betul ke tempat yang betul sayang.
Kiranya ionic bond ni macam gap ion dengan anion lah kan?
Ya, memang cat ion and ion, bukan macam sayang. Elektron tu diberi kepada siapa? Sebelum ni kita belajar, kita buang elektron, kita terima elektron. So kat sini kita kena fokus, elektron tu dari siapa yang kita bagi tu? Alright, siapa yang dapat? Okay. So kita tunjuklah sebenarnya.
Okay, thank you
Alright.
Miss.
Sure. Others?
Excuse me, Miss.
Yes.
May I ask for the Piston noble gas configuration and half-filled orbital? In the answer, should we mention like, because for normal gas configuration, we normally will write sodium donate one electron to achieve stable octet electron arrangement, right? So for pseudo-normal gas configuration, do we need to mention this name, or we can just write that the atom donate electron to achieve stable octet electron configuration?
No, you still need to mention at this moment, the moment just now, we started to learn your noble gas configuration stability and pseudo noble gas configuration stability. We will be no longer using octet.
Okay.
Okay, unless the question is not comparing between the type of stability, then octet still acceptable somehow. But if you are having pseudo noble gas configuration, then we will use pseudo noble gas configuration. Okay.
So we have to mention the specific name. Okay,
Yes,
sure.
of course. Thank you.
Got one more question. Is about the quiz 3.
Mm-hmm.
I have doubt on whether the oxidation number is fixed, whether on element and ions also, or oxidation number only for ions.
I don't understand the question. Oxidation number is like charge.
Yeah, so it's present in elements also.
Element is neutral. It present for the ion lah. But the question can ask what is the stable oxidation number for this element. So in the other word, what is actually the stable charge for this element?
Oh, okay.
I think the biggest difference between oxidation number and charge, all right, is the way that you write. Okay, just very quick. If it's a charge, then it will become 2 minus. If it's an oxidation number, then it should be -2.
Okay, sure.
This is the biggest difference, only, to be honest.
So for the quiz 3, got one question mentioned that W has 12 protons. Choose the correct statements about W. So the oxidation number is +2 is acceptable for it lah.
Yeah,
But the question didn't mention about ions, right?
yeah. Oxidation, I mean, you can work it out there. It's the same thing. You can work it out there.
Sure.
Alright, you can work it out there.
Thank you, Miss.
Sure, sure. Lim, is there any question?
Goodbye.
Thank you.
No matter, no miss, I just listen only.
Sampat, that is what we call. Thank you. Thank
See
you. Sure.
whether I mislook what.
All right. All right, cool. Thank you.
Okay, thank you, miss.